So we're going to run a sinusoidal regression. In order to do a sine regression, the calculator must be in radian mode, and the good news is your calculator is just going to be in radian mode, right? Unless you make the change to degrees, right? Which you would have to do. And you might have, because we've done some stuff, some of the early stuff in the book, and there was a little bit of stuff in degrees. On the diploma, any quizzes, whatever, there will be no degrees, right? So you just clear your calculator, or it'll be cleared for you during the diploma, and it will be in radian mode, and you just leave it there. So what we're going to do is take some real life data, which can be modeled by a sinusoidal equation. We're going to run a sinusoidal regression. We're going to look at the equation, look at the values of A, B, C, and D, and say, well, what does that tell us about it? So that's basically what we did yesterday, right? So once we run the regression, we're pretty much into yesterday's stuff. What are A, B, C, and D? What do they mean in the context of this question? And then we can do the graph, which takes us back to the second day's stuff, which is, hey, here's a graph, and what does that tell us? And that's all we need to know about sinusoidal. So, data. Oh, I should slide this a bit, right? Can't. This is Calgary, Alberta, Canada, climate data. This is Calgary average monthly climate data and extremes. So here's the daily average in degrees Celsius for January, February, March, April, etc. Here's standard deviation, which you know about a little bit, but doesn't matter for us. There's daily max, daily min, extreme max, and the date, and the extreme min, and the date. Right, so it hit minus 45 in February of some date, which is off the screen there, but whatever. Okay, so what we'll do is daily average, right? So what's the average daily temperature in January? It's negative 8.9 degrees. So we're interested in this column here, right? And this is going to go into L2, and the January, February is going to go into L1. So you need your calculator. So in L1, so you go to Stat, Edit. If your calculator is clear, you see L1. If for some reason you go in to do a regression, you don't see an L1, it starts off at L2, clear your calculator, right? Run through the clearing thing. If there's data in there, because generally the sinusoidal tends to be like the last questions on the exam, just go second, plus, second plus memory, clear all lists. So if you have previous list data, just clear it out. Okay, so stat, edit. In L1, we're putting the number of the month, right? So January is 1, February, March, April, May, June, July. So we have the numbers 1 through 12. Okay, pop over to the next column, and in L2, we are now going to put the temperatures. So negative 8.9, yeah, nice. I hate this thing. 88, 8.9, negative 6.1, negative 1.9. Okay, at least we're in April now. We've hit positive territory. So the average daily temperature for the month of April should be 4.6, 9.8. 13.8, 16.2. So all they do is just measure the temperature every day, right? And then they average that out, the daily average temperature. So they measure the temperature all day, they figure out an average for the day, and then for this chart, they figure out an average for the month, right? So they take all of those January average temperatures, average them together, and get an average for January, and so on. Okay, August 15.6, September 10.8, and hang on, I'm going to have to slide over. Okay, October, month 10, 5.4, November, negative 3.1, and negative 7.4. Okay, so that's the data. if you're doing a quiz, test, field test, diploma exam, etc., whatever, check it over, go back through, make sure the numbers are correct. In class, it doesn't matter so much, just your numbers will differ from ours, and that's how you'll know you made a mistake. Okay, stat, calc, sine reg. It's down towards the bottom, so I just arrow up, right? Because there it is. It's in this one, it's C, sine reg. Pen in the calculator. Don't do anything. If you have one of these guys, don't do it. Just you go down to store regression equation, and you put in a y1. If you have TI 83 or 84 without, it should say sine reg. Just put in a y1. Don't do anything else. Okay. So on this, don't do anything. Just put a y1 into the store regression equation. And if you're running off the calculator that doesn't have this menu, it should say sine reg y1. Only we had done something like that before. If you're looking for an explanation of why your mark is what it is, now you know. Okay, so it's thinking to put this in. Your other calculator says sine reg y1. Hit enter. Okay, so it'll run the regression. It runs the regression, this is what it comes up with, right? Now on an exam, you don't really care, okay, because it's in y1. On a quiz or test, I'm asking you for the regression equation. You're going to have to write that down. Okay, so I'm going to ask, and I'll tell you what to round it to. So, you know, if we say round it to the nearest, let's say to 3 decimal places, right? Because we have a little bit more. So you would write y equals 12.720, right? That's your A. Sine B, 0.507, so bracket 0.507x, minus 1.985, and then plus 3.652. Okay, so here, let's go to here where we can actually write this out. So y is equal to, what is it, 12.720. Sine 0.50, what did we say, 7x minus, what was it? 1.985 plus 3.652. Okay, so now we are where we were yesterday. Here's an equation in the form y equals a sine bx plus c plus d. We can write down, right? So a is 12.720, b is 0.507, c is negative 1.985, and d is 3.652. We're dealing with temperatures. And in dealing with temperatures, our L1, or our x-axis, right? So the x-axis is the month number, and the y-axis is the temperature. Okay, so the y-axis is the temperature. So if we graph this, I want to go to, well, before we graph it, we could talk about, right? So y-axis, so x-axis is month, x values is month, and y is temperature. Okay, of A, B, C, and D, which ones are the y value? So 2 of these are y's and 2 of these are x's. Which ones are y's? A and D, right? So therefore the x's are B and C. So if I'm talking about anything to do with A or D, then I'm going to use degrees Celsius, right? These are temperatures, so A and D are in degrees Celsius, and B and C are in months. Okay, so D is 3.652 degrees. right? Because it's a y-axis number. So what is this 3.652 degrees? What does that mean in the context of the problem? Average temperature. So year-round, the average temperature in this godforsaken city, year-round, the average temperature is like less than 4 degrees Celsius, right? 3.652 degrees Celsius. This is the median temperature in Calgary. So it means half the year it is warmer than 3.652 degrees, and half the year it is colder than 3.652 degrees. Right? You should be at this point questioning, why do I live here? 4 degrees, right, is the average temperature. I mean, okay, so that's the median temperature in Calgary. What does it mean? Half the year it is warmer than 3.652 degrees, and half the year it is colder. So it's the average, the median, the middle temperature, right? Middle temperature, half the year is colder than 3.652 degrees. Okay, what's A? Or what does it mean? I think the number A, it's right there. It's like 12.72. So what's the 12.720? Difference from the average, right? So what's the maximum temperature in Calgary? So maximum is D plus A, right? So it's from the middle, right? Because what's A? It's the amplitude. What's the amplitude? It's how much you vary from the median or the middle. So you will go 12.720 degrees warmer than, so we got 3.652 plus 12.720. Which is what? 16.372 degrees. Yeah. Okay. So the warmest daily temperature. Remember, this is an average daily temperature. I mean, we know that in summer it gets warmer than that, right? But on an average daily temperature, on the hottest day of the year, it's still reasonably cool in Calgary overnight. Okay. This isn't back east. Where you want to, so this number is higher back east, but then you also get places where, it cooled down to 30 degrees at night, and I don't have air conditioning, right? And it's tough to sleep when it's 30 degrees. So our maximum temperature is 16.372, remember, as an average daily temperature, right? And what's the minimum? So minimum is D minus A. Right? So I mean, it's possible you get a question like this. They just give you the temperature in Calgary is, Y. For the average daily temperature for a month in Calgary, Y. For a month X is, and it says, what's the maximum temperature in Calgary, right? Or what's the minimum temperature in Calgary, minimum average? So we get 3.652 minus 12.720, okay, which is what?
Negative 9.068.
Degrees, right? Make sure there's a degree symbol on there. This is not degrees like there's 360 of them in a circle. And it's like, who the heck came up with this idea of we should call temperature in degrees and we should measure angles in degrees? Like, yeah, really? Like, you're just going to use the same thing for two totally different things, right? Okay. Anyways, but they did, so. So our temperature is in degrees, and that's the most common degrees we use, right? People don't usually walk around talking about angles, so. If you're a pilot or something, then yeah, because you have to fly on a certain heading, and that's measured in degrees. But so the range of temperatures would be from negative 9.068 degrees to 16.372 degrees, right? So we're covering a range of a little bit over 25 Celsius degrees from the average, remember this is average. We know it gets a heck of a lot colder than -9, right? But that's the average daily minimum. Okay, that's the average daily maximum. This is the median year-round temperature, right? Okay, so B and C are going to be measured in months. So what are we going to do with the B, 0.507? So we got a formula. What formula involving B are we going to use here? So the period is 2 pi over B, which is 2 pi over 0.507, which is what? Some number. I'm not going to be surprised if it's in the vicinity of 12. 12.39. 12.39 what? Degrees. Yeah, it's 12. No, it's months, right? Okay, the X values are measured in months. And the B value is what changes. Remember, B value changes the period, right? Makes it longer or shorter period. So 12.39 months. How long is 12.39 months? About?
A year.
It's about a year, right? And that's what temperatures should repeat, right? Every year. We know that. We've lived here long enough to know that, well, it's really cold in December and January and February. It starts to warm up in March. It's April, May, June. It's going to kind of peak in the June, July region. Then it starts to drop off again. So 12.39 months. And then the one that you won't be asked to do, but we want to do this from the point of view of being able to look at this and draw the graph and talk about, well, where does it start? What's the start point? So the last thing we have is the start point, which is negative C over B comma D. So remember, that's a point on the graph, right? It's got an X value and a Y value. And the Y value is 3.652 degrees. Okay, so the X value is negative C, so we have that, right? Negative C is going to be positive 1.985. Let's just write it like this. 1.985 divided by 0.507 and 3.652. So what's 1.985 divided by 0.507? 3.915. What month is 3.915? And where in the month? So which month and where in the month? Yeah, near the end of March. All right. What happens near the end of March? Spring. Okay, now spring we know is really about 2/3 of the way through the month, right? You know, but they talk about, you know, there's spring as in our position in the orbit around the sun where the days are of equal lengths. He's a Chicago fan. So there's the definition of spring, which is the day when you hit the equinox, right? 12 hours of daylight, 12 hours. There's meteorological spring, which they usually talk about as being March 1st, I think, right? So it's like we've hit kind of that average. And then there's this spring, based on this, I guess, which is when we're going to first hit the average daily temperature, right? So when do we first hit that average temperature? In March, right? Because we know in January and February it's cold and then it starts to warm up. We hit the average in March. When are we going to hit it again? So we're going to go up above and we're going to come back down to that temperature. When's that going to happen? September, right? Yeah, around the end. Okay. I mean, no, it should be what? It should be fall. Fall, September 20th, 21st, around there. Right? That's when we should hit that temperature again. And then from that point, it just gets colder. right? Any relation to the length of days? I mean, obviously if the days are shorter, we're getting less heating from the sun and that, right? So longer days make sense that we have higher temperatures. Shorter day. So the temperatures kind of go along with hours of daylight, right? I mean, longer the day, we got more sunlight, we're getting hit by the sun. It's higher in the sky, right, which matters. So during this point, the sun is getting higher in the sky. You can actually produce vitamin D, which you can only do from about April 21st to about August 21st at this latitude, right, because of where we're at. The sun has to be high enough in the sky to come through to actually cause you to produce vitamin D through sunlight exposure. So it doesn't happen. You don't get any significant. It's not like you can go out in the sun in January and stand there and start producing. It's not going to happen, right? So even if it was a warm day in January, it wouldn't happen, right? Sun's too low. It's going through too much atmosphere, which is filtering out the rays, blah, 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 etc., right? You can do that. It's all science. Anyway, this is math. There's no science here. Okay, so if we're going to graph this, right? So we should know what the graph looks like, right? We know that we have 3.652 degrees, right? And we know that we have a maximum. Where was the maximum? It was like 15 point something, right? All right, so let's call that 16. We had a minimum, which was about like -10, right? I'm just approximating now, but it was 12.72 above and 12.72 below. And we've got months here, right? So let's come up with a scale. 2, 4, 6, 8, 10, 12. 2, 6, 8, 10, 12. And we know that it was around the end of this, right? It's like at month 3.9, we first hit the average, right? That's our start point. Now, how many pieces is a sine curve divided into?
4.
4. Good, right? And how big is each piece? Well, it's going to be a quarter of the period. Let's call the period 12 months, so it's about 3 months, right? Which is very seasonal, because that's how our seasons come, right? Every 3 months. Because there's 4 of them. Where am I? I'm on this page. So in 3 months, we're going to hit the peak. So that's going to be, this is around the end of month 3. So call it 4, so it'll be like 7, but the end of month 6. So we're going to hit the peak. 3 months later, right, September-ish, we're going to come back to the middle, right, because we go up to the maximum, back down to the middle. Then we come down again, so about 12 point whatever, we're going to hit the minimum, right? Or if we back up 3 months, we're going to be at a minimum, right? Because this is going up. So if we back up 3 months, it's going to put us about here. We're going to be at the minimum. So we're going to have this idea here. Can't see where I'm writing. And so on. So that's our temperature, right? This is Calgary. This is actual Calgary data. I didn't make stuff up, right? It's a page off the internet. So temp, average daily temp in, okay, so this is month. Well, that's our X. That's our Y. This is in months. And this is in degrees Celsius, right? All right, so let's see what happens if, so we put this into Y1, right? So we'll go to Y equals, I like to put in the average, right? 3.652. I won't bother putting in the max or the min. We need to set a window though, right? So what are we going to use for the window? What month are we going to start in? Let's start with 0, right? I mean, so month 1 is January. 0 is going to be December of the year before, right? That's fine. And how high out are we going to go? 12. Let's go to 13, right? Because we know the period is 12.39. So it doesn't matter. You could do 24. You could do 2 years, right? We could see 2 cycles, right? But if we're just looking at 1 cycle, scale 1, sure. You're splitting it into 13. That's good. What's our Y min? -10, right? We can get away with that because it was -9 point something. So -10 should actually show the minimum. What's the max? 17. So let's go to 20, right? Because 17 is just not, And And let's go by 2's. And let's hit graph. Right now it should look like this, yeah? In theory. Does it? Pretty close, right? I mean, yeah, it's close enough. Yes, so it is. It's true, it's true. Okay, and there's our average temperature coming along. All right, now, I could just give you that equation, or actually I could make you run the regression on that equation and then say, so what's the average daily temperature in the middle of July? So what month is the middle of July? So second calc, I need to put in a month. What month is the middle of July? 7.5. So when x is 7.5, middle of July, then the average daily temperature should be about 16 degrees Celsius. Okay. Remember, that's average. We know in the middle of July it's going to get, I mean, if it's going to get warm in Calgary, which is not a foregone conclusion, then, you know, it's going to get warm in the middle of July. So, but you know, it's still going to be maybe 10 degrees overnight, and then maybe 30 degrees during the day. And 10 and 30 is 40. That could average out to 20. Well, that's a little more peaky there, but. Okay, I run 2 sets of tires on my car. I have a set of summer-only tires, and I have a set of winters. Now, you should switch. First of all, if you're going to have a car in this city, you should run winter tires, right? The all seasons, nah, they don't work, okay? And if you're running pure summer tires, then you had better have a set of winter tires, or you're just going to park the vehicle. The switchover, we're going from summer to winter, or from winter to summer, is 7 degrees Celsius. When the average daily temperature is 7 degrees Celsius or higher, you can run on summer tires. If it's below 7 degrees Celsius, you need to run on winter tires, right? I mean, you can get away with all seasons below 7, but, okay, I don't have all seasons. So I'm going to go to y equals, and I'm going to get rid of the 3.652, and I can change that to 7 point. Okay, I don't need the zeros there. I should just clear it. 7. Okay, and I want to know, when do I change my tire, right? Because, so let's find out, right? Let's graph this. So here's the average daily temperature, right? And 7's going to be like 2, 4, 6, 7, just around here. Eventually, there. Okay, so there's the 7, right? So I can say, all right, where are we here? This is January. This is why I've made it 0, right? So I can say this is January, February, March, April. Okay, so it's after April. So when do I want to change? Or it's sometime in April. So second calc intersect. And I want to say, okay, fine. Where do these cross? You don't have to lift your finger up if you're doing this. So average daily temperature is 4.44. So January, February, March, April is 4.4, about halfway through April. So any time now, right? I don't actually switch till like May long weekend because we know we can get snow and stuff, right? But it's been a kind of a warm year this year, right? So, you know, maybe switching in mid-April isn't going to be too bad. You know, I get away with it, and if it snows, just drive really carefully, you know. But if it snows, it's not likely to get icy, right? I mean, when it snowed the other day, or it snowed last week, we got a lot of it, but it melts as soon as it hits the ground, right? Because the ground has warmed up, right? That's what happens in spring. Ground warms up, snow hits, disappears pretty quick. Doesn't mean we can't get, like, you know, a foot of snow in May, and it's going to stick around for a while, because just there's a lot of snow there, right? Just means I shouldn't probably drive if I've got my summer tires. Okay, so we hit 7 degrees at 4.44, so about the middle of April. And then when should I run? So now I've got my summer tires on here. And then when should I put the winters back on? So I need another intersection. Now this time I don't want to move over the hump here. I just want to go along the straight line. So I'm going to switch, right? This switches you from Y1 to Y2. And then I could just go along the straight line, just along the 7 degrees. long as I don't hold for 3 seconds, we're good. You can hold it down on your calculator, right? It's not gonna. Oh, like. Apple News. Pre-order your Apple. I already ordered it. It's like, come on. Wait. I don't even know what we want. Oh, the calculator. Okay. 1, 2, 3. 9.59, 9.6. So that's 2/3 of the way through September. Okay, now we know what happened in September of this year. Right. We got snow. The trees didn't have their winter season. I mean, if trees don't have leaves on them, then a heavy snow load, big deal, right? I mean, the odd branch may crack, but you got a lot of leaves on, you get heavy wet snow, it's like you're coming down. Okay, so I mean, the evergreens weren't hurt; they're used to it, right? They keep their needles all year; they're evergreen, and so they're fine with the snow load. The other trees, not so much. So 9.6. So I can run my summer tires from April. So far, we got like 5 months, I guess. I can run from about 4.6 to 9.6. So I can run my summers for about 5 months of the year. My winters should be running about 7 months of the year. Okay. If you have all seasons, you can get away with switching later and switching later, right? Like, you know, it's not going to matter. Or switching later, you know, even switching a bit earlier here, you can, you know, keep your winters for less time. Not a good idea to run winters all year just because they wear on, you know, when it's warmer out, they're going to wear that much faster. So, you know, you're just going to be spending more on tires. What'd you learn in math today? Well, we learned when to switch our tires. And so that's it, really, right? I mean, you could do multiple different, we could do a regression on whatever, but this is the idea, right? Is we have a set of data. We have a set of data which can be modeled by a sinusoidal function, right? So it's periodic, right? Periodic means it's going to repeat. And it's got some period with which it repeats. This, we're not surprised. It's a year, right? This average yearly temperature and stuff. We enter the data into our calculator, run a regression, come up with an equation. Now, from the equation, from the A, B, C, D, we know characteristics, right? And we're working within a context. So if I just give you a set of data and say run a sinusoidal regression, there's no context with that, right? All you could say is that the average is this, the amplitude is this, so it varies. But here, it's the average temperature. All right, so let's say that global warming is a thing, that it exists, right? So we'll pretend we are not in the United States. And we'll say global warming exists. Which of A, B, C, or D would be affected? Say it louder.
Is it B?
D. So I could change the period. Period's not going to change, right? I mean, we're still operating on a 1-year thing. The Earth is not going to start going around the sun every 2 years, right? So D can't change. A could possibly change, but we know that D would change, right? Because the average daily temperature should increase if there's global warming, which then it might not be so bad living in Calgary. Right? Get an average daily temperature, and you know, and if there's melting of the poles or something like that, we're far enough inland, we're not going to be affected. I mean, Vancouver and Los Angeles and New York, and too bad, guys. Like, you know, so you're under 2 meters of water now, where it used to be at, you know, we're 1,000 meters high. Like, you know, stuff melts, then well, of course, you get a lot of snow melt and rain, then we see what happens in Calgary. That's just flooding, though, right? But that's temporary; it's not permanent. So D would be affected, right? The average temperature would go up. The amplitude, likely not. The period, no. I mean, when spring starts, not going to be affected, right? The C values, right? You're still going to start in spring. Still likely have the same temperature swings. We'll just be operating from a different average temperature. Okay, questions? No? Yes? No? No?